This week's article of the week is titled The Flu Vaccine, Everything You Need to Know. Source, theweek.com, October 26, 2019. Getting a flu shot is a seasonal rite, but why do you need one every year and why doesn't it always work? Here's everything you need to know. How does the vaccine work? The flu vaccine contains inactive or weakened versions of 3 or 4 different strains of the influenza virus. Most people receive the vaccine via injection, but there's also a nasal spray available. The weakened viruses can't cause serious illness, but they trigger and train the immune system to fight off the invading microorganisms. White blood cells generate an army of antibodies, which attack and destroy the vaccine viruses by attaching themselves to part of the virus known as antigens. The vaccine antigens have the same shape as real flu antigens, so the immune system know how antibodies that match up with the real flu virus. The experience teaches the immune system to recognize future flu infections and quickly make antibodies to attack the invading viruses. It takes about 2 weeks after receiving the vaccine to develop immunity, which is why doctors recommend getting it early in the flu season, which begins in October and can last as late as May. Why do people get vaccinated? Do most people get vaccinated? No. Although the U.S. has one of the highest vaccination rates in the world, only 45% of adults and 63% of children get flu shots each year. Scientists estimate that if the vaccination rates were boosted to between 80 and 90%, it could effectively stop seasonal flu from spreading because of herd immunity. Influenza is one of the world's most contagious diseases, spreading easily through the air and by touch. It affects 5 and 15% of the world's population every year. The disease kills 12,000 Americans during mild flu season and up to 56,000 in severe ones, with 90% of the victims over 65 years old. Many people don't get vaccinated, however, either because they fear getting the shot or believe it's ineffective. How effective is it? The vaccine's effectiveness varies dramatically depending on how well it matches the virus circulating in a given season. In good years, the vaccine protects 50 to 70% of people receiving it, but some strands are more difficult to create vaccines for, such as the H3N2 type, which raged during the severe 2017 flu season. That year's vaccine was found to only be 40% effective overall. Nevertheless, doctors recommend getting the shot anyway because even some immunity helps slow the spread of the disease. Vaccination also can make symptoms of any flu infection less severe, even if it doesn't completely prevent illness. We do have something that works, says Peter Police, a virologist at the Antigens School of Medicine at Mount Sinai in New York. It's not perfect, but it's better than not having any vaccination. What makes flu so tricky? The flu virus is constantly mutating, rendering the body's antibodies against previous flu infections obsolete. Influenza is less stable than other viruses such as chickenpox because its main genetic material is RNA. The virus makes many small errors when it copies its genetic code during reproduction. Every generation of the flu virus has a slightly different genetic structure, which is harder for the immune system's existing antibodies to recognize. This process is known as antigenetic drift. Scientists have to guess which influenza strands will be more prevalent well before flu season starts to give pharmaceutical companies time to manufacture enough of the vaccine. How are vaccines made? The process hasn't changed much since the first flu vaccines were given to American soldiers in 1945. Over 90% of flu vaccines are incubated in fertilized chicken eggs because the virus grows extremely well in them. This technique is relatively cheap, but production is cumbersome and time-consuming, taking about 6 months. The World Health Organization issues predictions for the Northern Hemisphere flu season in February based on observational data and laboratory studies, with pharmaceutical companies beginning production almost immediately. The process requires about 900,000 chicken eggs per day. Given the 6-month time lag, it's all but impossible to swiftly order up vast new batches of vaccine in case an unexpected strain emerges, which is what happened in the 2009 to 10 flu season with the H1N1 virus, better known as swine flu. The virus infected an estimated 61 million people in the U.S., killing 12,000. Are improvements possible? In theory, yes. President Trump issued an executive order in September directing the Department of Health and Human Services to create a flu vaccine task force to modernize seasonal vaccine production. However, the order does not provide any additional funding for vaccine development. Experts say it could take decades to develop the sophisticated new infrastructure needed to make vaccines in animal cells instead of eggs. Egg production is a huge bottleneck, says Martin Fried, coordinator of the Initiative for Vaccine Research at the World Health Organization. You can't just call your local egg farm and say, "Tomorrow I need 10 million more eggs." A universal flu vaccine. The holy grail of flu research is a universal vaccine that would provide lasting protection against all forms of the virus, but it remains elusive. There have been clinical trials in the past with the National Institutes of Health beginning a new round of tests on humans this year. The hope is to train the immune system by targeting the stem of a protein on the virus, which varies little from strain to strain. However, our bodies don't generate many antibodies to target that part of the virus, instead focusing on the frequently changing head because of a process called imprinting, in which the immune system learns how to fight viruses based on its first encounter. It's difficult to teach the body new habits. I don't think we are that close at all, says Michael Alsterholm, director of the University of Minnesota Center for Infectious Disease Research and Policy. I think the kind of work that's gone on has been critical and important, but it's only the first 5 feet of what would need to be a 100-foot rope. Thank you for listening. Your possible response questions this week that you must answer, all 3 of them, are 1. What are your thoughts on the flu vaccine? Explain. 2. Pick a word, line, passage from the article and respond to it. And 3. Discuss a move made by the writer in this piece that you think is good or interesting. Explain. After answering these 3 questions, you must write a full 1-page reflection. If you want to talk about your experience with the flu vaccine, you may do so as well. Thank you for listening, and do not forget that this is due on Friday.